ladies and gentlemen, we're back. We're going to start our first of 5. Yes, you heard it, 5 days dealing with factoring quadratics. And here's day 1. But before we get into factoring, because it's been 2 years since most of you have done factoring, we're going to go back to reviewing multiplying binomials just because a lot of you are still struggling with that. So remember, multiplying binomials is that FOIL acronym, first, outer, inner, last. So when we take this first one, we multiply our first ones. X times x is not x, it's not 2x, it's x squared. X times negative 3 is negative 3x. 4 times x is plus 4x. And 4 times negative 3 is minus 12. Make sure you watch your signs, and then make sure you combine your like terms. And I see that I have a negative 3x and a plus 4x, which means my answer is x squared plus 1x minus 12. You can write the 1 in there if you'd like. Moving to the next one. This one now has the coefficient out front of one of the terms. So now we've got x times 2x, which is 2x squared. X times negative 5, so minus 5x. Negative 7 times 2x is minus 14x. Negative 7 times negative 5 is plus 35. When we combine our like terms of negative 5x, negative 14x, we get 2x squared minus 19x plus 35. Then we've got this next one, 6x plus 1, 6x minus 1. These ones are called conjugates. And we call them conjugates because they're the exact same terms, except one has a binomial with a plus and one has a binomial with a minus. Otherwise, they're identical. So when we multiply these out, 6x times 6x is 36x squared. 6x minus times negative 1 is negative 6x. 1 times 6x is plus 6x. And 1 times negative 1 is minus 1. When we combine our like terms here, we got minus 6x plus 6x. These cancel each other out. That's why they call them conjugates, giving us 36x squared minus 1. Now remember though, this only works when it's a plus 1 and a minus 1. If they're both identical, it will not work that way. Finally, we've got 4x minus 8 quantity squared. Some of you still insist upon distributing that exponent. We never, ever, 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 ever distribute an exponent. So this really means 4x minus 8 times 4x minus 8. And we still have some of you that, even though you recognize that, are still then only distributing and doing the first terms and the last terms. You have to do all 4. So we get 16x squared minus 32x minus 32x again, and plus 64. When we combine those two like terms in the middle, we get 16x squared minus 64x plus 64. So now that we've had some of that practice, let's get into factoring. Our 2 factoring methods for today are GCF and difference of squares. Starting with that GCF, what we need to first do is find the GCF of all the terms, and then we're going to divide it out of all the terms. I look here and I see that 10x cubed is one of my terms, and negative 5x squared is my other term. Both of them can be divided by 5. They can also both be divided by x squared. So I'm going to write that I'm dividing them both by 5x squared. The one thing you have to remember is nothing disappears. There is no equal sign. Therefore, the 5x squared isn't disappearing. It's coming to the outside of a set of parentheses that we're now throwing in. 10x cubed divided by 5x squared is 2x. And negative 5x squared divided by positive 5x squared is negative 1. So my fully factored answer is going to be 5x squared times the quantity 2x minus 1. And you want to always make sure you check, 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 check. You don't have to write out your check, but we should be checking our work to make sure that if we distribute this back in, 5x squared times 2x is 10x cubed, And 5x squared times negative 1 is negative 5x squared. We want to make sure we get back to what we started with. Looking at our next one, we have 6x squared minus 54. We see that they both can be divided by a 6. You cannot go bigger than the smallest number. You guys learned that when you learned about GCF. And they don't both have x's in them, so that's all we can divide out. If we divide out a 6 and pull that out, it's like undistributing. We are left with x squared, and then we have a minus 9. Now I will tell you that this here is special, and you'll see that in a little bit as to why that's special and how we can further factor that. But for right now, 6 times x squared minus 9 is going to be our final answer. Here we have 3 terms. And when we have 3 terms, it has to divide out of all 3. It cannot divide out of 2 of them. So I see that all of them are divisible by 2. And I see all of them have an x in it. We can't go higher than one of the x's because this term only has an x to a power of 1. So if we divide out a 2x, we will be left with x squared and then plus 2 minus 1x or minus x. And this is also special, and we will talk about that coming up here in the coming days with how you might possibly be able to factor that. Our last type, this one, these are the ones that most of you will struggle with, but it's interesting because these are the easiest ones. I've already done the dividing out for you and breaking it up because I could rewrite this one here. When I break it up, I could write it as 2x times x squared plus 2x times 2 plus 2x times negative x. I could write it as that and see that all of them have the 2x in common, but I didn't have to. Here, I look and I see both of these have an x plus 4 in common. So what I do is I pull out that x plus 4, and what's left is 3x plus 4. However, we need to throw that into parentheses just to separate it out. That's it for GCF. Now let's take a quick look at what we call difference of squares. I notice that x squared is a perfect square, so is 81. I see that 9y squared is a perfect square, and so is 25. 1 is a perfect square, so is 49p squared. Therefore, if you have that and you have a minus sign in between, we follow our rule that says if you have a squared minus b squared, you take a plus b and a minus b. Well, this is how I want you to show your work. The square root of x squared, well, that's x, because x times x is x squared. Square root of 81 is 9. Therefore, my answer is going to be x plus 9 times x minus 9. Pretty simple. So then the next one, we need to take the square root of 9y squared and the square root of 25. Square root of 9y squared, square root of 9 is 3, square root of y squared is y, square root of 25 is 5. Therefore, you get 3y plus 5 times 3y minus 5. And you can flip-flop and say 3y minus 5 times 3y plus 5. Doesn't really matter. This next one is square root. We need square root 1. And we need to square root 49p squared. Square root of 1 is 1. Square root of 49 is 7. Square root of p squared is p. Therefore, we have 1 plus 7p times 1 minus 7p. And I know we typically put the variable terms first, but no, you cannot flip-flop these, because if you flip-flop them, you're changing the problem. So what I need you to do now is give these 3, make sure there's only 3, yep. Give these 3 you try problems a shot. Enter your answers, write your summaries, and as always, bring your questions with you